Hey everybody, I'm Tim James. I'm a founding engineer here at Decodable. Today I'm going to demo, in particular, the Decodable S3 sync connection. We'll be using Decodable to process streaming HTTP logs in Envoy format into typed data, streaming that to objects in S3, and then using AWS Athena to perform ad hoc batch SQL queries on that data in S3. So you might imagine we might be doing other real-time processing on these inbound HTTP logs, but we also want to ask questions about recent historical data, about web traffic, like which paths are seeing elevated error rates. That can kind of feed into building out other real-time functionality to serve the business. If you've never used Athena before, it's a lot like Hive. If you've never used Hive before, it uses SQL. So we're very much staying in an SQL world today. I'll talk us through how we securely write to S3 buckets in our customers' AWS accounts. So if you're using this in your AWS account, and how we partition the objects put to S3 to optimize those Athena or Hive queries. So without further, I'll share my screen. Yeah, just a moment. Great. So as you can see, I've got 3 running decodable connections. 2 are of S3 sync type. We're going to talk through those today. And then 1 is the data gen. Now, every decodable account comes stock with a data gen Envoy connection. It's just an easy way to get started with data that's actually already flowing. And our getting started guide will talk you through how to build some of this yourself. So this Envoy connection has a single field. Under the covers, this is going to be generating data as simple text records. But because it's SQL, we have to have a field to work with that information. If we look at this actual data from the Envoy raw stream that we produce here, we can look at the stream. So this, again, here's just this one value field in Envoy raw. If we look at that data, here we see it expressed in JSON format, just with this value name. And then here is that textual data. If you've seen HTTP logs before, if you've seen Envoy logs before, this is going to look really familiar. We've got a timestamp, we've got a method, we've got a path. We've got a whole bunch of stats about each request, and we've got an HTTP status code. So right. From here, we're going to use a pipeline to convert that data, that raw textual data, into typed SQL data. And this typed data is going to carry us all the way through to S3, where it will be stored in typed Parquet format, and then into Athena queries. So for that, we use a pipeline. This is our demo pipeline. As you can see, we're just running at about 10 records per second. So this is generated data. This is not a high throughput rate for this demonstration, but it does scale. So the way we handle that is with this SQL query. This is the same one in our getting started guide, but I'll talk through this now. So first, we're going to be inserting into the HTTP events stream. Let's just take a quick look at that. So this is the final schema that we'll be working with all the way through to the end of this demonstration. You can see timestamp, method, path, protocol response code. all the things that we saw in that incoming data, but now it has proper SQL types that we can run queries on using typical SQL logic. So to do that, again, we're in this pipeline. This is actually 2 nested select statements. I'm going to go ahead and run a preview on this. That's going to take about 20 seconds to show us just the last 10 lines so we can get a sense of what this is going to deliver. The inner SQL statement uses a grok function. Grok is a very common parsing tool. It's based on regular expressions. That's going to divide up that input data into named fields. Again, timestamp, method, path. This should start to look familiar. Those fields here come as an SQL map, and then we use this outer SQL statement to map those to named SQL fields with types, the timestamp, the string, the int, etc. And the ultimate output from this ends up looking like this. So now we start to see that we're dealing with not textual data, but semantically available data. So we can see there. Okay, let's go. So from this pipeline, we need to read from HTTP events and write that type data to SQL, or to S3, excuse me. How do we do that? We use an S3 connection. So here's our first S3 connection. It's connected to S3. It's inbound from our HTTP event stream. As you see, it's the same, almost 10 records per second. The schema matches what we saw for HTTP events, so it matches the output from our pipeline. All this should look familiar. And this is how it connects to S3. So first, we're going to be writing in the Parquet format. That's a columnar format that is efficient for tools like Athena and Hive to read, even across many objects, where it defaults in the same region. The bucket is assumed to be in the same region as the AWS account. If you want to write to a bucket a different region, you need only put that region name here. We recommend leaving your bucket in the AWS account of your, the AWS region of your Decodable account, so as to keep that data within that region. So we have a bucket name. We're writing to a particular directory within that bucket. So this would be your customer, your own IAM role. And we'll talk later about how that works and how we do that securely. But effectively, you, the customer, are giving us, a third-party Decodable, permission to take certain actions within your bucket and potentially directory, and only on behalf of your account. And we'll get into the details in that a little later. We're going to partition this by timestamp. So the timestamp by default is going to break into year, month, and day, and we will see that in the bucket in just a moment. And we're using, in this case, the snappy compression scheme. So here we are in this bucket. We have, as I said, so we're in Decodable Tim Demo 1 bucket, Demo 1 day directory. We're in year 2022, month 3, and then here's all of our day partitions. Right, so here's today, and as we see, this already has more than 1,000 objects. Now, this is a great partitioning for use by Athena, because it likes to have more objects and fewer partitions, but it's not so much a great partitioning for this demo. So we also have a different connector, a different connection where I have partitioned these by minute. And so here we're breaking up the timestamp explicitly by year, month, day, hour, and minute, just so we can see the objects show up. So we'll go back here. So we're writing to this directory right here. You can see these side by side. So again, year, month, day, but now we're chopping these up by hour and then by minute. So here we just have a few of these, and if I reload, we should see, and there's a fifth object. So you can see we're actually streaming data here. Unlike the one we're going to use, the connection output that we're going to use with Athena, this I have typed as JSON instead of Parquet, so that we can pop this open and see that in fact we're dealing with, here it is, the same data that's run all the way through. It's JSON typed at this point. And this is what would be available to downstream tools, in this case in JSON format. So one thing I want to point out here is, so we use, with our S3 connection, we use two-phase commit transactions. So we get exactly one semantics all the way to S3. If we're to stop this connection, so this is the minute connection, I'm going to pause it by hitting stop here. And sometimes this will leave an uncommitted object here. It didn't do it this time. It only does it sometimes. But the idea is when we restart this and it recovers, it's going to it's going to recover the final incompletely committed transaction, grab that uncommitted S3 object, and change its name so that it is committed. When it's uncommitted, it's just prefixed with an underscore, which is the signal to tools like Hive and Athena to ignore that object. And that is for exactly this kind of exactly once scenario that we're dealing with here with a two-phase commit. Another thing worth seeing is that so if we look at the previous minute and what is now the current minute, what we'll see is that the last committed object from the previous minutes shares a commit ID and therefore an object name with the first committed object here. So what's happened is that this commit has spanned these two partitions. So that gives you a sense of how we manage some of the partitioning in the face of the transaction logic that we provide. Great, so now that we know that we have data, the data is flowing, we can go and use Athena to actually ask some interesting questions of this data. So here we are in Athena. I have made an Athena table called Tim Demo 1 Day. It is, you'll see all these same typed columns that we're used to. And then there's these three others, the year, month, and day, that you'll recognize from the partition. So these aren't part of the original schema. The S3 connection has created them. Athena uses these through a predicate pushdown to optimize its queries. So if you specify a year or a year and a month, and day, it's going to scan less than the full amount of data in that directory in the bucket. So the first thing we want to do to use Athena is to load our partitions. So we'll go ahead and do that. This takes just a few seconds when it's partitioned by day. We should see that pop up in just a second. There it is. So query successful. We load our partitions so that we know that we've got that data available to all of our queries in Athena. Now, I made this table with Athena DDL. This is stored in AWS Glue, but it's actually easier to work with directly with Athena here, I find. So if we just do a show create table, this is just the query that we ran originally. Again, here's all of our typed values. Here's our partitions. Here's some information about that we're using Parquet. Here's where it lives in S3, and here's our Parquet compression. So, right, so let's look at the data. Here's the simplest query we can start with. We're just gonna grab 10 rows from here. Once again, here we are, our timestamp, our method, our path. This should all look very familiar. We can ask more interesting queries. Let's say that we wanna look at the slowest queries across this table. So the slowest requests available in our data set, ones with the highest duration. We can just order by duration, we run this. This takes a few seconds, and there it is. This is all generated data, so all of our durations are 99 and lower. But in real data, we would see more interesting output. Let's say that we want to do some aggregation. This is a very handy ad hoc query. So we're going to average by duration, and we're going to count them, but we're going to aggregate by path. And response code. So takes a little longer, and you can see now we can see these durations. So if we were interested in seeing whether certain response codes at certain paths were slower, now we're able to see that. Now, what we're doing here, because I don't have a where, we're querying over all the data in the data set. So what we want to do is start to use those partitions that we built thusly. So we're just going to grab some data, but we're only looking at the 18th of March in this case. Now we'll see the last query we did scanned 30 megabytes, but as we run this one, this is going to be a lot faster. And this is only going to scan 30 kilobytes because we're looking at data only on the 18th. So you can see that this is in fact data from the 18th. I'm going to do one more of these, and then we're going to dive into how we connect to S3 in detail. But I want to give you the sense of the power of this integrated system between Decodable and Athena. So we're going to run this. Yeah, again, this is just data from the 18th. But we're aggregating by original path. I'm just using an average here. Of course, for real production systems, we'd be looking at more like quantiles, P99, P95, that sort of thing of request duration. So that's what you can do with Athena. It's easy to get this in. If you've got HTTP logs flowing, it's really easy to get them all the way over to Athena. Let's talk about how we do that. So the first thing I'm going to do is create a fresh bucket here. Right, so we're going to start. Now, our other bucket was named Decodable Tim Demo 1A. Demo 1, we're going to call this Demo 1-A. It's going to be the same US West 2 region. I'm going to borrow its settings from our previous bucket, just so this is fast. Okay, we're going to leave everything non-public by default, so everything's closed off to the world, and we're going to only allow decodable access using IAM roles and policies. I'm leaving versioning off because as I want to be able to age out these. I want to be able to age out these objects over time without leaving them in our bucket. So let's go ahead and create that bucket. Great, so now we have bucket demo 1A. So the next thing I want to do is let's create a connection to talk to that bucket. So we're going to go to connections. We're going to create a new connection. It's going to be a sync. We're going to send data to S3. We're going to call this demo 1A. Say next. We can use Parquet format here. We're going to read data again from HTTP events. So this is the output from our pipeline. So this is borrowed the schema from the HTTP events stream. So we know that it matches the pipeline's output. We're in the same US West 2 region. Our bucket name is demo 1A. We're going to say that this is in the 1-A directory. Now, if we were to I'll say this. So we're going to need an IAM role. The IAM role that we used before only has permission to talk to our older bucket that we looked at earlier. So we need a new one to talk to this new bucket. So to get that, let me kind of step you through how this happens. I'm going to borrow this IAM role, and it's going to not work. I'm just going to say timestamp for the partition template. And we're going to say snappy compression, right? So first thing, I'm going to step you through all the ways that we can make mistakes in this and then fix the mistakes to show you all the parts that are doing their thing. So first I'm going to use a bad partition template name like that, and it is going to tell me that I cannot. There's no such field here. So to get past that error, I have to use a real partition template, a real column name in the partition template. If I try this again, now I have a different error. So we failed to put this S3 object to this bucket because access is denied. So we were able to assume this role, but it can't talk to our new bucket. So what if we imagine we have a different role ARN that we haven't created yet? If we create this connection, then it says that we're not authorized to perform assume role. That's because the role doesn't exist. So we're going to fix that error by causing this role to exist. So the first thing that I'm going to do is go into roles. I'm going to create a new role here. So this is going to be the trusted entity type is an AWS account. Traffic requests to your S3 bucket are going to come from Decodable's S3 account. So what we need to do is say that we get this from Decodable's S3 account. We keep that number in our S3 connection documentation. So our Decodable AWS account is this number right here. We put it here. In this case, I happen to be using our S3, our AWS account for this demo. If you do this, your account number would be here, and our Decodable AWS account would be here. So now the next step is that we require an external ID to represent your Decodable account. Now, to get that, the Decodable account name is right here. So this is Tim Demo Account 1. And that goes right here. This is doing it this way is the best practice when a third party will assume this role. Decodable is that third party. Whenever Decodable writes data to your S3 bucket, it will always use the external ID that matches your Decodable account ID. No other Decodable account can talk to your bucket because requests from other Decodable accounts would use their Decodable account ID. because you specified both the originating AWS account as decodables and your decodable account ID as the external ID, you can be assured that Decodable won't mix up whose buckets belong to whose decodable accounts. You can be assured of that, not because we promise not to mix them up, but because you provide access only for your own decodable account. This problem is known as the confused deputy problem, and AWS has a great paper on this if you'd like to read more about it in depth. Our documentation touches on this as well, and it links to that paper. So we have created the role. Next thing we're going to do is add permission policies. I'm actually going to skip this at first because we're going to step through this in a different way. We're going to give it a role name. Again, this is account 1A. This is the JSON, the trust policy that's generated from the wizard right there. As you can see, here's Decodable's account ID, and here's our demo decodable account ID as well. So we don't have any permissions yet. That's on purpose for this demo. We're going to go ahead and create the role. And now we have our role. I'll open that up here. Great. So I'm going to go ahead and copy this ARN back over to here. I actually ended up using a different ARN name. But now this is a role that we can actually assume. So what we'll see when we create the connection is that the error message changes. So we'll go ahead and do that. Now we see that this is access denied. So we've assumed the role, we've assumed our brand new role, but it doesn't have access to the bucket yet. Why? Because we haven't given it permissions yet. So we're going to add permissions here. So we are going to go ahead and attach a policy. We're going to create a policy over here. I'm just going to go ahead and edit the JSON. And I'm going to go ahead and borrow this policy straight from our decodable documentation. So that's here. And I can just copy paste this right in there. And you can see that we're allowing put, get, and delete on the bucket. I want to use the proper bucket name. So I've got that here and here. And then list bucket on the bucket directly. Don't need any tags, don't need to say anything else. We do need a name. So I'm going to give it this name. And we create this policy. Now we go back here and we can find that policy name that we just created. We go ahead and attach it to our role, Decodable Tim Demo 1, which matches this ARN. And now when we create the connection, bam, it creates, because we have permission all the way through to write to S3 in the customer bucket. We haven't processed any records yet. Let's go ahead and start that up. And then when we go ahead and look at this bucket, in about a minute, this is going to start having keys and objects in it. So that's the demo.